Okay, for video assignment number 2. So basically what we want to find are the equilibrium partial pressures of the three gases in the above reaction. The reaction highlighted being N2 plus O2 equals 2NO. That's the balanced reaction that we have there. So in the problem it said to look up the normal partial pressures of nitrogen and oxygen gases in dry air. So here we find 0.78 and 0.21, so that's kind of where we get those values. But let's start from the beginning. Kp is 0.05 as given in the reaction. We have our products, the concentration at equilibrium of the products over the concentration of the reactants. And so we use the ICE table to be able to find the initial ATM. As we know, as I just talked about, is 0.78 for N2, 0.21 for O2, and the reaction hasn't happened yet, so 0 for NO. The change in ATM is going to be minus X, because there is no exponent right there. Minus X for O2 as well, plus 2X because the exponent is 2. And then ATM, well, that's when we use this equation right here. We took this info, all right here, initial ATM and change in ATM, to be able to create this equation right here. So 2x squared, as shown here. And then, as shown here, N2.78 minus x is going to be right there on the bottom, as you can see. And then 0.21 minus x, as shown right here, this relationship. And so simplifying that out, 4x squared over x squared minus 0.99x plus 0.638 equals 0.05. And then multiplying this side by both sides, we get 0.05x squared minus 0.0495x plus 0.00819 equals 4x squared. We subtract 4x from both sides. I'll do that really quick. There we go, from both sides. And then you get this equation. Negative 3.95x squared minus, and then all of the rest of that equals 0. I threw that into my calculator, TI-84, using the quadratic formula option. And given these two options, then obviously x cannot equal negative 0.052, because if that were true, then you would have a negative ATM for NO. 2 times negative 0.052 would be a negative number. So it has to be the positive number, 0.0397. You plug that in on each of these. This is going to be, 0.78 minus 0.0397 equals 0.7403 ATM. 0.21 minus 0.0397 is 0.2497 ATM. And then 0.0397 times 2 is going to be 0.0794 ATM. So those are the equilibrium partial pressures of the three gases, as explained in the above reaction.